Hello friends, this video is created by Siddharth Upadhyay, founder and creator of PrepWings. Log on to www.prepwings.com for complete free course videos. In this video, we'll discuss few advanced level questions of probability. We will also look at the at least one case for probability. So now the question here states that 3 cards are drawn out one at a time from a normal deck of cards without replacement. Find the probability when exactly 2 of them to be hearts and 1 is club. So 2 of the cards are hearts and 1 is club. So here we need exactly 2 hearts and 1 club. So first we'll calculate the probability that the first card is heart, the second is heart and the third is club. The cards are drawn without replacement. Okay, thus probability for the first to be heart will be 13 by 52. Probability for second to be heart will be 12 by 51 because we are withdrawing it without replacement. So 51 cards are left when I am withdrawing the second card and 12 of them are hearts. And the probability for third to be club will be 13 upon 50 because there are 13 clubs left out of 50 cards now. Okay, so now we know that probability of first heart and second heart and third club is calculated by multiplying the above 3 probabilities. That will be 13 by 52 into 12 by 51 into 13 by 50. So the probability of first heart and second heart and third club is equal to 13 upon 850. Okay. But keep in mind, we don't have to calculate the probability for the first heart and second heart and third club. We have to find the probability to get 2 hearts and 1 club. Okay. So the probability that we found out is of a particular order, wherein the first is a heart, second is a heart, third is a club. Okay. So we will have to look at other possible orders as well. Okay. So if we look at it, case 1 can be we get the first heart, second heart and third club, which is HHC. Okay. So that is the probability that we found out. Case 2 will be HCH, where the first is a heart, second is a club and third is a heart. Case 3 will be CHH, where the first is a club, second is a heart and third is a heart. So we can get 2 hearts and 1 club in any of the 3 cases. And probability of each case will come out to be 13 by 850 when we calculate. So now to get exactly 2 hearts and 1 club, we can get either case 1 or case 2 or case 3. Okay, and these cases are mutually exclusive. So probability to get exactly 2 hearts and 1 clubs will be then equal to probability of case 1 plus probability of case 2 plus probability of case 3. Now we know probability of case 1 equal to probability of case 2 equal to probability of case 3, which in this case is 13 upon 850. Okay, so probability to get exactly 2 hearts and 1 club will be equal to probability of case 1 multiplied by 3, which is 13 by 850 into 3, which equals to 39 upon 850. Thus probability to get exactly 2 hearts and 1 club will be 39 upon 850 here. Okay. So now we'll look at the method that we followed. So whenever we do not have the order, exact order, like in the previous question it says 2 hearts and 1 club, there was no order for it. Then what we'll do is we'll calculate the probability of any one case, like any particular case. We'll find the total number of cases then, and then the required probability will be equal to probability of any one case multiplied by the number of cases. Okay. So we'll look at one more example to gain more clarity. So now the question says a dice is rolled 8 times. Find the probability to get exactly 5 threes. Okay. So over here if you look at it, we have not been given the order. See, what we have been given is we need to get exactly 5 threes. Okay. So let us first find the probability to get first 5 threes and next 3 not threes. Okay. So we are gonna find the probability of a particular order first. So over here we have shown the first 5 rolls we get 3 and the last 3 rolls we do not get a 3. Okay. So probability to get a 3 on one roll is 1 by 6 and probability to not get a 3 on a single roll is 5 by 6. Okay, because then apart from 3, any other 5 elements can come. Okay. So now probability for the above case will be then 1 by 6 raised to 5 into 5 by 6 raised to 3. Okay, because to get each 3 we need the probability is 1 by 6. Okay, and we'll be getting the probability of the first 3 and the second 3 and the third 3 and the fourth 3 and the fifth 3 and then the not 3 and then again the not 3 and then again the not 3. So we have to multiply all these probabilities. Okay, so we will multiply 1 by 6 5 times and 5 by 6 3 times. So the probability for this case will be 1 by 6 raised to 5 into 5 by 6 raised to 3. Now if you look at it, the number of ways we can arrange now these 5 3s and 3 not 3s is 8C5. Okay, because we found out the probability for only one particular order. Then we have to find the number of orders that are possible or number of ways we can arrange them. So number of ways we can arrange them is 8C5. So our required probability will be probability of one case multiplied by number of cases. So in this case, probability to get exactly 5 3s will be then equal to 1 by 6 raised to 5 into 5 by 6 raised to 3 into 8C5. Okay, so this is how we solve this question. Now when you roll a dice, you will either get 1 or 2 or 3 or 4 or 5 or 6. Okay, so the probability to get any one of them will be equal to 1. Okay, because it will happen. Okay, when you roll a dice, either you'll get 1 or 2 or 3 or 4 or 5 or 6. So the probability for it has to be 1. Thus, for a scenario, total probability of all cases taken is equal to 1. Okay. So probability for at least one case will always be equal to 1 minus probability for the 0 case. Okay. To understand more about probability for at least one case, we will look at an example now. Now the question here says that a dice is rolled 5 times. Find the probability to get at least 1 3. So now we know that the dice is rolled 5 times. Okay, so we will get either exactly 0 3s or exactly 1 3 or exactly 2 of them to be 3s or exactly 3 of them to be 3s or exactly 4 of them to be 3s or exactly all 5 of them to be 3s. Okay, so probability to get 0 3s plus probability to get 1 3 plus probability to get 2 3s plus probability to get 3 3s plus probability to get 4 3s plus probability to get 5 3s should be equal to 1, because we have exhausted all our scenarios now. Okay, so now what have we been asked to find? We have been asked to find probability to get at least 1 3. So that will be equal to probability to get 1 3 plus probability to get 2 3s plus probability to get 3 3s plus probability to get 4 3s plus probability to get 5 3s. Okay, that is the thing for at least one case, because at least one case means one or more than one. Okay, so we can get 1 3 or more than 1 3. Okay, so this is what we have to find. So looking at from the formula above, probability to get 1 3 plus probability to get 2 3s plus probability to get 3 3s plus probability to get 4 3s plus probability to get 5 3s will be 1 minus probability to get 0 3s. Okay, so now if you look at it, we are rolling the dice 5 times. Okay, probability to not get a 3 on one roll is 5 by 6. Okay, so on one roll probability to get not a 3 is 5 by 6, but we are rolling it 5 times. So probability to get 0 3s, that means I am not getting a 3 5 times. So what will be the probability to get 0 3? It will be 5 by 6 raised to 5. Okay, because it will be 5 by 6, 5 by 6, 5 by 6, 5 times. Okay, so it will be 5 by 6 raised to 5. Thus probability to get at least 1 3 will then be equal to 1 minus 5 by 6 raised to 5. Okay, so probability to get at least 1 3 is 1 minus 5 by 6 raised to 5. Okay, so that is all about advanced probability concepts. Thanks a lot for watching this video.